I am Vaibhav Srivastav from Vaibhav E-Learning Academy. Today we are going to start a new topic in chemistry, that is atomic structure. This is our part number 1. In today's video we are going to cover some basic concepts. This is a very advanced topic. We will be covering some basic concepts of atomic structure, starting with what is matter and what are the classifications of matter, then what is an atom, theories about the atoms, and then some what are the parts of atom, then what are the models of atom. We will be discussing these things in today's video. So let us start with today's video, atomic structure. So the term atom came from a Greek word atomio. Here the word atom is from atomio, which means undivisible. Indivisible or undivisible. Atomio, it means that you cannot divide it further. So this was about atom. So from where this atom came? In our daily life, we use one word commonly, which is called matter. What is matter? Basically, from from young age, we are learning what is matter. The very basic definition of matter is anything that occupies space and has mass is called matter. So any object which occupies space and has mass is called matter. This matter was used since the starting of the time. Like these all stories started from 1700, 1800. So matter is anything that occupies space and has mass. That is matter. Now people started dividing the matter. It means that subdivisions of matter. So here we have matter. They started classifications. First one is physical classification. And the second one is chemical classification. Chemical classification. Physical classification and chemical classification. These physical classifications are of 3 types. First type is solid. Second one is liquid. Third one is gas. Solids, liquids and gases are the physical classification. Now this chemical classification, we have 2 types. First one is pure substance and second one is mixture. Pure substances and mixture. So this is one type, physical classification. This is chemical classification. Both are separate. This mixture is basically of 2 types. First one is homogeneous and second one is heterogeneous. Homogeneous mixture and heterogeneous mixture. These are the 2 types of mixtures. These pure substances are further classified into 2 types. First one is elements. Second one is compounds. Pure substances are of 2 types. First type is element. Second type is compound. Then the second type of compound is, the types of compounds are 2 types. Organic and inorganic. This is the basic flowchart about matter which you will find almost everywhere. Matter is of 2 types. First type is physical classification. Second type is chemical classification. Physical classification we have classified into 3 types: solid, liquid and gas. Then chemical classification are of 2 types: pure substances and mixtures. Mixtures are of 2 types: homogeneous and heterogeneous. And pure substances are of 2 types: elements and compounds. In compounds we have organic compounds and inorganic compounds. So let us start with solids, liquids and gases. Solids, we all know anything which is having a definite volume and a definite mass. Liquid, it has a definite volume but not a definite shape. Solid has definite mass and definite shape. Gases do not have definite mass and do not have a definite shape. So these are the basic physical classification. Chemical classification, one is pure substance, one is mixture. Pure substances are the unique substances, you can say. They are like, on their own they are unique. They are pure, they are not mixed of anything. And mixture is a mixture of any two things. For example, now homogeneous mixture. If you take water and sugar, if you add them both, if you mix them properly, they mix together nicely. Homogeneous mixture means there is no residue left. Solvent and solute. If you mix them both, you get solution. That solution do not have any leftover particle. That is homogeneous mixture. Heterogeneous mixture. For example, you take a glass of water and put some soil in it, and then you mix it. After some time, if you look that the soil is settled down and the water is floating upside, that is heterogeneous mixture. These pure substances are of two types: elements and compounds. Elements, compounds. Elements each are a separate element. For example, hydrogen, lithium, oxygen, nitrogen, and sodium, potassium, etc. Compounds are mixtures of elements. They are pure substances, but still they are mixtures of elements. Two or more elements combine in simple ratio to form compound. These compound can be of two types: organic compound and inorganic compound. What are organic compounds? The compounds which are mostly made up of carbon, hydrogen and oxygen. Organic are just made up of C, H and O. For example, glucose, C6H12O6, or methane, CH4, etc. Inorganic compounds which are made up of other elements which do not have carbon. The elements which do not have carbon, for example, ammonia, nitrous oxide, etc. So these are organic compounds and these are inorganic compounds. So this was the basic classification of what is matter. Physical, chemical. Physical has solid, liquid, gases. Chemical has pure substances and mixtures. Mixtures have homogeneous mixture and heterogeneous mixture. Pure substance have elements and compound. Compounds have organic compounds and inorganic compounds. This was the first classification. Now, after this classification, many theories started coming up. Theories about what is atom. People started to think, what are they made up of? What are the objects around them made up of? Many people started by saying that the body is made up of 5 substances, that is air, water, fire, soil and the underground. So these all things. Then the second theory was that Maharishi Kannad gave that everything is made up of manus and anus and parmanus. After that stories were, these were very mythological things. But the first scientific explanation was given by John Dalton. John Dalton in 1808. In 1808, he proposed a theory which is called Dalton's theory, Dalton's atomic theory. So he had so many points to give about what is an atom. People had that idea that everything is made up of molecules. Every molecule is made up of atom. He described what is an atom. The first and main thing which he said was, all the things around us are made up of molecules. And these molecules in turn are made up of atoms. This was his first point. All the things around us are made up of molecules which are in turn made up of atoms. Second point was, atoms can be neither created nor be destroyed. This was the second point he said. Atoms can neither be created nor be destroyed. Then the next point he said that atoms of same element have same physical property, have same properties. Atoms of same element have the same property. For example, you take 2 oxygen atom, 2 carbon atom, they will always have the same property. Then he said atoms of different element can never have same properties. Can never have same properties. For example, two elements you are taking, oxygen and nitrogen, they can never have same properties. Okay. These are the basic points which he gave. All the things around us are made up of molecules which are made up of atoms. Atoms can neither be created nor be destroyed. Atoms of same element have same properties. Atoms of different elements have different properties. Atoms cannot be subdivided it cannot be divisible. It cannot be divisible. It means you can't divide atom more. And one more point which he said was atom cannot be divisible. Yeah. And last point, atoms are the smallest indivisible particles that take part in a chemical reaction. So these are the 6 points, major points which he gave. He also gave so many points, but these are the main points which he gave. All the things around us are made up of molecules which are in turn made up of atoms. Atoms can neither be created nor be destroyed. Atoms of same elements have same properties. Atoms of different elements can never have same property. Atoms cannot be divisible. Atoms are the smallest indivisible particles that take part in a chemical reaction. Obviously, in recent times, everything of this is failed because all the things around us are made up of molecules. This point is a correct point. We can approve this. Atoms can be neither created nor be destroyed. This thing was valid up to the 19th century. Now it's from the 20th century. Atoms can be created. How can they be created? There are some new types of reaction called nuclear reactions. These are the nuclear reaction which will make new atoms. One atom of an element can be converted into another element. So that is what you can destroy an element and you can also create an atom of elements also. Atoms of same element have same properties. This thing was discarded by isotopes. What are isotopes? Now, what is an isotope? Atoms of same element have different masses. This is the main thing. Atoms of same element have different masses. For example, if you are taking C12 isotope, C12. Here you have 12, here you have 13 and C14. So these are the three isotopes, C12, C13, C14. Here also you can take even hydrogen. 1, 2, 3. Protium, deuterium, tritium. Carbon 12 isotope, carbon 13, carbon 14. Here, for example, if you take any element X, here Y, here Z. X is the atom of the element, X is the element, Y is the mass and Z is the atomic number. So here, atoms of the same element have the same properties. But isotope says atoms of the same element have different mass. Same element, carbon, 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 same atomic number 12, but the masses are different. 12 grams, 13 grams, 14 grams, 12 AMU, 13 AMU, 14 AMU. Can have the same properties. Hydrogen, there are only one element of hydrogen, 1, 1, 1, but their mass is different, 1, 2 and 3. So this isotopes discarded this property, that is atoms of same element have same property. Nowadays atoms of same elements also have different properties. Second one, atoms of different elements can never have same properties. This thing was discarded by isobars. What are isobars? Isobars say that atoms of different elements can have same mass number. Actually there are two atoms. Both the atoms will have the same number of mass, but they are from different elements. Two atoms of different elements have the same number of same mass. For isobars, examples given were like argon and potassium. Argon and potassium, they both have different atomic number. Argon atomic number is 18 and potassium as 19. But their mass number are same. Argon and potassium. They are different elements. One has atomic number 18, one has atomic number 19. But their masses are same. What did this point say? Atoms of different elements can never have same property. These both are different elements, one property is same. What is that property? Physical property. Which physical property? Mass. Mass is same. So that is why this point was also discarded. Then, atoms cannot be divisible. This point was discarded about the discovery of electrons, protons, neutrons. These three are called subatomic particles. These three, after the discovery of these three particles, this point was also discarded. Atoms are the smallest indivisible particles that take part in a chemical reaction. This part is correct if you exclude this word. These indivisible particles, they are divisible into electrons, protons and neutrons. Atoms, yes, are the smallest particles which take part in a chemical reaction, but they are not indivisible, they are divisible. So this was the theory given by John Dalton. It was his postulates and these are the drawbacks. This is why this theory failed. So this was the first theory given by someone. It was a scientific theory. John Dalton gave a scientific theory which was appreciated and approved. For almost 50 to 70 years, this theory was intact. People believed this theory. People they believed all these points and that also made some sense. But after the discovery of the subatomic particles, this theory was a complete flop. Now, let us see the discovery of subatomic particles starting from electron, proton and neutron. Let us see. So now, we will be learning about discoveries of some subatomic particles. Now, what are subatomic particles? Till now, according to John Dalton, that the atom is undivisible. The atom cannot be divided. But since the discovery of subatomic particles, his theory failed. What are subatomic particles? The particles which are inside the atom are called subatomic particles. The common subatomic particles are electron, protons, neutrons, ions, neutrino and electrinos. So electron, proton, neutron, pion, neutrino, electrinos and many of them. There are so many subatomic particles. Most of them are almost invisible. You cannot see them. These are the subatomic particles. But mostly these three, electrons, protons and neutrons, these are the fundamental subatomic particles. Fundamental subatomic particles. These three are the main subatomic particles. These only were useful in the discoveries. They were discovered very nicely and they had most of the theories behind them. They had most of the biggest experiments. We'll be starting with the first one, that is electron. So starting with the discovery of electron. Discovery of electron. Electron, it is represented as E minus, like this, because it has a negative charge. We'll see about that. So electron was discovered by two people. First one, William Crookes, and second one, J.J. Thomson. William Crookes and J.J. Thomson, they performed one experiment. This is a very famous experiment. From here, this is one tube. This is one plate, electrode. A connector. This is the connector. So here, this is called, this whole device over here, this was named as discharge tube. discharge tube. This discharge tube was used in experiments. So here, this is the battery, this is the vacuum pump, these are electrodes. So let me say, this one has a negative charge, this one has a positive charge. Negative charge and a positive charge. So the positive charge was called as anode and the negative charge was called as cathode. Negative charge over here, it is called cathode, and positive side is anode. Cathode and anode. These are electrodes. So now J.J. Thomson performed an experiment. In that he kept the gas at 10 to the power minus 2 mm Hg mercury pressure, and he applied a voltage potential of 10,000 volt. He applied 10,000 voltage potential and gas at very low pressure, 10 power minus 2 mm to 10 power minus 3 mm Hg, 2 to 3. So after that he observed. After observing, he found that there are some rays which are coming out of the cathode. So these rays like this, and they were going towards the anode. He named these rays as cathode rays. Who named this as cathode rays? J.J. Thomson named it as cathode rays. He observed that these rays were going from this side to this side, from cathode to anode. On the basis of that, he made some points. He noted some points and he gave some characteristics or some properties. So let us note the properties of these cathode rays. First property, they travel from cathode to anode. Now he made so many properties, but I am going to discuss only the few basic ones. They travel from cathode to anode. Cathode to anode, negative charge to positively charged. Negative to positive. Inside that cathode there are some charged particles. Which charged particles will go towards positive charge? Positive and positive repels. Negative and positive attracts. Positive and negative attracts, and negative repels. So it means that if there is something inside this cathode rays which is telling it to move towards the anode side, then these cathode rays are negatively charged. They travel from cathode to anode, and second point which the main point has, they are made up of electrons, or you can say made up of negatively charged particles called electron. This is the point. They are made up of negatively charged particles called electron. The third point is these cathode rays are invisible. If they are invisible, how did they find out about these cathode rays? First point, they perforated the anode. Perforation means making some holes inside these anode rays. They perforated this electrode and they applied a screen over here. This screen was made up of ZNS, zinc sulfide. This is called fluorescent screen. On this screen, if any particle shine on that, if any particle goes towards that screen, if it touches that screen glows. That is why that is called fluorescence screen. These cathode rays, they went through this perforated anode and they hit on the ZNS wall. So by that they said that, J.J. Thomson said, they travel in straight lines. Straight lines. In this, one more point is added. They travel in straight lines in the absence of electric and magnetic field. In the presence of electric and magnetic field, they deflect their direction. In one, they go towards the anode side. In the second one, they turn towards the south pole. So, they travel in straight lines. This is the point of cathode. So they travel from cathode to anode. They are made up of negatively charged particles called electrons. They travel in straight line. Now the main point comes. They have kinetic energy. They are opaque. They are you can say that they travel in straight line. How did they travel in straight line? If you put any object over here, for example, if you put any opaque object which forms a shadow backside, you will see that those particles do not deflect somewhere else. For example, you put a particle over here and then you apply ZNS screen over here and here. These won't deflect this side or that side. They will either get absorbed or pass through the particle and go towards that side. That is one point. Second point is they rotate any paddle wheel which are present. So inside these in this discharge tube, if you put a wheel which is called a paddle wheel, they are very light, like their mass will be very, very low. So whenever the cathode rays hits that wheel, they start rotating. It means that they have some energy. It means they have kinetic energy. Any object which is in motion possesses one energy called kinetic energy. When these rays hit the paddle wheel, the kinetic energy turns into mechanical energy. Kinetic energy, potential energy, mechanical energy, which helps it to move. After moving, then these cathode rays were not absorbed here. It means that these charged particles have some energy inside them, and if you use up their energy, they won't be visible over that side. These are some main points regarding the cathode rays. Then comes another point. They are independent on the nature of the gas or electrode. For example, here you have some gas, hydrogen gas. If you change the gas, if you put some another gas also, they will show the same property. If you change this electrode, if you made it out of some another metal, then also they will show the same property. So they are independent on the nature of gas or electrode. And one more point, which is one of the important points of cathode rays. If a cathode ray hits any hard metal like tungsten, if a cathode ray is made to strike on a hard metal like tungsten, tungsten, then they produce some rays. The scientist who performed this experiment did not know the name of these rays, so he named them X-rays. Until now, we use the name X-rays only. So if any cathode rays hits a very hard metal like tungsten, it produces some ray which is called X-rays, which can go through the body. So that is why we use X-rays as the name. So these are the discovery of electron. Electron was discovered by J.J. Thomson and William Crookes. This experiment was called Crookes experiment. In this experiment, J.J. Thomson did this experiment. The main thing of this experiment was he decreased the pressure, increased the voltage. Then these things happen, and they travel from cathode to anode. They are made up of negative charge particles. They travel in straight line. They are independent on the nature of gas or the electrode. So from here, electrons were discovered as a subatomic particle. Why? How did they discover that electron is inside? Because they took the gas, right? They decreased the pressure so much so that the gas cannot move here and there very fastly. Decreasing the pressure, it will be still slowly. Increasing the voltage with a high speed, these cathode rays, some rays were going towards the atoms. From these atoms, electrons were ejected. This electron ejection went towards the anode and it hit on the screen. So it means that inside the atom there are some things, some particles. That particles were named as electrons. They have a charge of -1, that is why they are written as E-1. This is about the electron. If you see the mass, it is 9.1 into 10 to the power of -27 gram. This is the mass of the electron, and the charge is 1.6 into 10 to the power -19 coulomb. This is the mass and this is the charge of the electron. Mass of the electron, charge of the electron. Mass and charge. So, mass of the electron and charge of the electron. charge of the electron, that is one, these both were found by an interesting experiment. This experiment was called Millikan's oil drop experiment. Millikan, he was a scientist who performed an experiment which is called oil drop experiment. He used a beaker from which there were two electrodes. There were holes in this, and there was one pump which had oil. It sprinkled the oil particles, very fine oil particles. He applied electrostatic force on this side, and this was the gravitational force. So he made such things that gravitation force pulled the oil droplet downward, electrostatic force pulled it upward. He made such an experiment that the oil droplet was still. Gravitation was pulling it from downside, electrostatic was pulling it from upside. So he used that experiment to determine the mass and charge, and finally he determined the E/M ratio of the electron. This is some another story which we will not be discussing over here. So we finally found about one subatomic particle which is called electron. While doing this experiment, J.J. Thomson remarked one more thing, that electron is not only the subatomic particle inside an atom, there are two more subatomic particles inside the atom. Then here comes the discovery of proton. Proton discovery was not such a great deal, it was not such a big one, because electron has a negative charge. Why did J.J. Thomson say that atoms have one more particle? It is because he discovered electrons. Electrons have negative charge. Atom is electrically neutral. It means that the number of positive charge is equals to number of negative charge. He just found the negative charge. There is something positive also which is left, and that positive thing is called the proton. Let us see the discovery of the proton. How was proton discovered? So now we will be discussing the second one, that is the discovery of proton, which is P+. So this experiment was also with the help of discharge tube experiment, because you know one thing, that if someone tries something and it becomes successful, other people also start trying that. Similarly, J.J. Thomson used this tube and he found, this is called the discharge tube. He did this discharge tube experiment and he found one subatomic particle. He also said there is another subatomic particle. So to find out that subatomic particle, many scientists started doing so many experiments with this discharge tube. Some tried changing the electrode, maintaining the constant, some tried giving low voltage, more pressure, etc. etc. One experiment which was successful was by Goldstein. Goldstein discovered proton. Goldstein discovered proton. What he did was, he used the pressure, not very low pressure, it was 10 to the power minus 1 mmHg mercury, and he perforated cathode instead of anode. This electrode he perforated like this. He perforated this cathode instead of anode. Previously anode was perforated. And this ZNS screen was applied over this side. Fluorescent screen. And then he started it. So not this side, the ZNS screen wasn't here. Just a basic screen. I mean normal, nothing over here. This side was the ZNS screen. So he used this pressure and he used perforated cathode, and then he put some gases inside and he started his experiment. He observed, like these are the gas ions, molecules present, which is having positive charge and an negative charge, positive, negative, positive, negative. He observed some rays coming from anode going towards the cathode. He observed some rays coming from cathode and going towards anode. He called these rays as anode rays. And he also named them as canal rays, because they were moving like a canal. After this, these type of rays were being attracted from positive side to negative side, from anode to cathode, positive to negative. Now, if there is something which is going towards the negative side, then which type of charge it is having? If you have something negative over here and any charge, you don't know what charge it is, and this is negatively charged, if this is being attracted towards this side, it means this has positive charge. This is negative, then this is positive, then only you get attracted to this positive charge, sorry, negative charge. Then he concluded that anode rays have positive charge particles, and he called them protons. This is the discovery of the second subatomic particle, discovery of proton. Now try to understand how were the protons discovered. Understanding this requires some logic. For example, now you take one atom, because these are the gases, gases are moving here and there, because the pressure is very low pressure, that's why they are able to move somewhat. These rays hit on this. This is a positive charge. The proton is having positive charge. An atom has two charges, positive charge and negative charge, according to that time. One was electron, which was discovered, one was proton, which is being discovered. So it means it has positive as well as negative. Positive, negative, positive, negative, positive, negative. If there are some rays coming from positive side, these rays have something positive, right? Anode rays have positively charged particles. Then these rays have something positively charged. When these positively charged rays hit one atom, when they hit one atom, due to this positive charge, the electron gets removed. The electron gets removed from the atom, and that's it. It doesn't go towards that side, because they do not have that more energy. They have the sufficient amount of energy to remove electron from the proton. Proton have positive charge, electron have negative charge. They both, due to electrostatic force of attraction, they are combined. If you give them sufficient energy, the electron can be removed from the proton. This energy is called ionization energy. The energy required for the element to be removed from the nucleus is called ionization energy. So that sufficient amount of energy this anode rays are having, when they hit the element, the electrons come outside. Similarly, from here, electrons are coming outside. Hitting this, electrons come outside. These are straight line only, so just drawing for representation. After the electrons came out, what is remaining? Positive charge is remaining. Once the electron exits the atom, positive charge still remaining inside the atom. These positive charge get attracted towards the cathode rays. Why? Because cathode has negative charge, atoms remaining positive charge. Let me again explain. These anode rays, they have positive charge. When they hit the atom, the electron comes out of the atom and it stays this side. And the proton, which is remaining inside the atom, because only electron came outside, the positive charge is still remaining. This positive charge gets attracted towards the cathode, which has negative charge. These rays he called anode rays, and these particles he called protons. There are no very unique characters of anode rays. That's it. They have positively charged particles and they are dependent on the gas and electrode. They are dependent on the gas and the electrode. If you change the gas, if you are changing the gas, for example, hydrogen has small atomic number, less amount of energy is required to remove electron. If you take a gas with a higher number of higher atoms, for example, oxygen, nitrogen, they have big atomic masses. More energy is required to remove them. If you do not change each electrode decides the energy of the cathode ray. You have to change the electrode if you are changing the gas. You have to change the gas if you are changing the electrode. So the cathode rays value depends upon many different kinds of gases. So that is why we say that they are dependent on the gas and electrode. Let us talk about mass and charge. Now the fundamental particle which is discovered over here is proton. The mass of the proton is 1.625 into 10 to the power of minus 27 kilogram. This is the mass of the proton, 1.6 into 10 to the power of minus 27 kg. And the charge of the proton is 1.6 into 10 to the power of 19 minus 19. So here electron had the negative charge, negative 1.6, and proton has positive charge. So you can say that the relative mass of proton is plus 1, relative mass of electron is minus 1. This is the discovery of proton. Then comes the discovery of neutron. neutron was discovered by James Chadwick. What he did was he bombarded beryllium. Let me write over here. Because discovery of neutrons was not such a great deal, it was not a bigger deal or something. So here discovery of neutron. Discovery of neutron was not such a. He took beryllium particles, bombarded with alpha particles, which gave him carbon 12 plus neutron. This was the equation which he gave. Beryllium bombarded with alpha particles which gave carbon plus neutron. This is called an alpha particle. What is an alpha particle? Helium with plus 2 charge is called an alpha particle. So he bombarded beryllium with helium. He got carbon with neutron. So that's it. That was not a bigger deal. But this neutron discovery was very late. This was discovered in 1942 almost. 1942 by James Chadwick. Why it was very late to discover this? Why it took this much effort to discover the neutron? It is because it did not have any charge. This was chargeless. Neutron had no charge. No charge on neutron. If you apply positive charge or negative charge, it was not going to be attracted to anything. That is why it was very hard to discover neutron. Neutron was discovered. It's like people started thinking about neutron after Rutherford's alpha ray scattering experiment. So before that, what was the mass of neutron? The mass of neutron is 1.675 into 10 to the power of minus 27 kg. Same. 1.6 into 10 to the power minus 27 kg. One more thing, that the nucleus is consistent of proton and neutron. Protons and neutron are consisting of the nucleus. The nucleus is in the center which has protons and neutrons. This nucleus will be explained by Rutherford. So now let us discuss about one very important experiment which is called the Rutherford's before Rutherford's alpha ray scattering experiment, we will discuss about some models. Atomic models. First model was given by J.J. Thomson. His model is called the plum pudding model. In that, this is the electron according to him, and this is the plum pudding model. So according to him, this is a model. This was a model given by J.J. Thomson. He got Nobel Prize for giving this model, but still it failed. It failed, but still he got Nobel Prize because this was the first model. No one ever else gave a model. This is called plum pudding. Plum pudding model or watermelon model. What is watermelon model? So according to him, the whole electron is a positively charged ball. The whole atom. The whole atom is a positive charged ball, and electrons are embedded. And electrons are embedded in it equally. It means that the whole atom is made up of positively charged. The whole atom is a positive charge. For example, if you are taking watermelon, the whole red color mass, according to him, was positively charged, and the seeds in the watermelon are electrons which are embedded. Because atom is electrically neutral. It means that the number of negative charge and the number of positive charge was equal to 0. Number of electrons plus number of protons is equals to 0. So according to him, that the whole circle was made up of proton, the whole circle was positively charged, and electrons were equally distributed everywhere. This model is called plum pudding model or watermelon model. According to him, the whole atom is a positively charged ball and the electrons are embedded inside that ball equally. This was the first model which was given by J.J. Thomson. Then after this model actually failed because it did not explain about the neutron. What is a neutron? He did not had any work on the neutron. And he did not explain the experiment given by Rutherford. This Rutherford alpha ray scattering experiment, this changed everything. This found what is neutron. This experiment was a very big experiment. It was made on a large scale. And according to that, one model was there which actually defeated this J.J. Thomson's atomic model. So this was the first model given by J.J. Thomson, which was his atomic model. Second model is Rutherford's atomic model, which was given after an experiment. So let us see what was that experiment. First, what he did was, this experiment name is Rutherford's alpha rays scattering experiment. So, what he did was, he took a source of what? A source of a radioactive element. This is a radioactive source. What is radioactivity? Radioactivity is the element it excites itself and de-excites. Excitation of an element. This excitation, one more model will explain, that is Bohr's atomic model. Because this Rutherford's model will also fail, after that one model will come, Bohr's atomic model, which will explain what is excitation and de-excitation. So radioactive element is an element which can undergo excitation on its own. One example which I had given was hydrogen 3. This is called tritium. This is also a radioactive element. So this radioactive source, it passed some beams. These rays are called alpha rays. What is a beam? A bunch of rays is called alpha rays. These alpha rays were made to pass through a plate. This plate is called lead plate. Why he chose lead? Because lead is a metal which can stop the alpha rays from scattering too much, because these rays are very excited rays. They can go here and there, but PB, that is plumbum, which is PB plate, lead plate, it actually does not allow the alpha rays to scatter here and there. So from this PB plate, it went through another plate. This is called gold foil. And here there is a screen, or let me write this over here. This is a gold foil. A very thin gold foil. This screen is ZNS screen, zinc sulfide screen, fluorescent screen. Then he saw something like this. What is this? This is called the alpha ray scattering experiment. He had a radioactive source which produced alpha rays which went through lead plate. From that it went towards a gold foil, and from this gold foil, this ray started scattering here and there. Most of the rays hit it straight, some hit it sidewise and some very large angles, some reflected back. This was the experiment, and this made the team shock. Because the team was in shock after this, because they did not know about the nucleus. He discovered what is nucleus. So expected was that everything will go through here in a straight, but it started scattering here and there. So now we will see what is the reason for this scattering. We will see why was it a scattering experiment. According to his model, there is a mass which is present inside the center, and that mass is called nucleus according to him. So this is an atom. This is the nucleus. This is what he gave. These are the terms which he gave. So the alpha rays, actually here is the screen, okay? Alpha rays passed like this. like this. On an average, he projected almost 20,000 alpha rays. This 1 ray, 2 ray, 3 ray, like that, 20,000 almost he projected. Each time this ray hits this, a shining happens here. This is ZNS screen. Each time this shines, it means that yes, this alpha ray has reached you. This is a positively charged atom. Okay, this is a positively charged nucleus. According to Rutherford, here are the electrons. According to Rutherford, the electrons are present in the outermost shell of the atom. So, the alpha rays, these are also positively charged rays. And you know one thing, positive repels. So if there was any ray which came somewhat close to this nucleus, then it started little bit deflection. Like this. From here also, little bit deflection. Because they were kind of close to the nucleus, not neutron, nucleus. Some of them, this is what one thing was given by him, that the majority of alpha rays were undeviated. Majority of the alpha rays were undeviated because majority went like this, some went like this, this. Mostly they went straight and they hit it on the screen. So majority of the alpha rays were undeviated. Then some of the alpha rays showed deviation with very small angle, which means that this was the expected, this is the angle change. Expected was to go like this, but it deflected a little bit with a very small angle. And when there were any rays which came too much close to this, they were deflected at a very large angle. Too much close, they were deflected, not touched, they were deflected. Very large angle, because the nucleus, this is a positively charged. If any positive ray is going towards positive, it will get repelled. If you take two magnets with the north and north pole, they will start repelling each other. This repulsion was very big repulsion. So some of the alpha rays showed deviation in very small angle. Very less alpha rays showed large deviation up to 90 degree. Till 90 degree they showed the deviation from here like this. And almost 1 to 2 of the 20,000 rays directly hit, like not even hit it. It almost just touched it and came back. Only 1 or 2 of the 20,000. Very rare. Alpha particles or alpha rays, not particles, rays, deflected 180 degree. It is because these positive came too much close to this positive that it started repelling it to the exact 180 degree repulsion. So, majority of the rays were undeviated. Some of them, like this ZNS screen was actually till like almost a very big screen. So, if any radiation, if any rays show large deflection also, they were able to notice that. When one atom came little bit close to it, it showed little bit deviation. When any ray came too much close to the nucleus, it showed large deviation. When any ray almost touched the nucleus, it showed complete deviation, 180 degree deviation. According to this experiment conclusion, he gave his model of atom, which is called the solar system model of the atom. So Rutherford's alpha ray scattering experiment was a very big experiment. It was performed on a very large scale, and the result of this experiment was also very much unexpected. So his model of atom was, this is the atom, this is the nucleus, this is the electron. He said that the electrons revolve around the nucleus in circular orbits. mind this, in circular orbits. Bohr said one atom, electrons revolve around the nucleus in fixed circular orbit. Fixed circular orbit and circular orbit. This will make a very big confusion later on. So here the electron revolves around the nucleus. This was called as the solar system model. Solar system model. This was given by Rutherford. According to him, that the size of atom is equals to 10 to the power of minus 10 meter, and size of nucleus is equals to 10 to the power minus 15 meter. 10 to the power minus 10 is 0.00000000000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. This much meters is the size of one atom. Do you see the difference between size of atom and size of nucleus? If you compare this, the size of atom is 10 to the power of 5 times the size of nucleus. It means that 10 to the power 5 is equals to 1, 0, 0, 0, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Almost 1 lakh times the atom is bigger than the nucleus. Almost 100,000 times the atom is greater than the nucleus. In the NCERT book, the example has been given that if you take nucleus as a ball, as a tennis ball, and you are taking atom as a field of radius 5 kilometers. This is a ball. This has a radius of 5 kilometers in each direction. This is the size of the atom. The nucleus is so small that if you take a ball and 5 kilometers around it, if you circle it, that will be the approximate size of an atom. Not in that scale, in negative scale. So the size of the atom is 10 to the power minus 10 meter, and size of nucleus is 10 to the power minus 15 meter, which says that size of the atom is 10 to the power 5 times bigger than the size of the nucleus. Now, why did this atom fail then? Why did this model fail actually? Not atom. Why did the model fail? So, for this there is one theory. According to classical laws of electrodynamics, we have to listen this. According to classical laws of electrodynamics, any charged particle in motion radiates energy. Any charged particle radiates energy or shows radiation in the form of energy. According to the classical laws of electrodynamics, any charged particles in motion, any charged particle in motion radiates energy. This was a big point. According to classical laws of electrodynamics, any charged particle in motion radiates energy. Electron is a charged particle. It has negative charge. If it is moving, because it is a charged particle and it is in motion, it radiates some energy. It means that its internal energy decreases slowly. Each time it is revolving, the energy decreases and it slowly is being pulled inside the nucleus. So, according to this, the electron will slowly go like this, then like this, like this, like this, like this, and finally it will fall inside the nucleus. It will collapse. But does this happen in real life? No. This marker is made up of an atom. The electrons are rotating around the nucleus. But is this collapsing? No, it is still stable like this. It means that this model is a failure, because according to this electrodynamics laws, any charged particle which is in motion will radiate energy. So if it starts from here, it will slowly lose energy. It will go towards the nucleus and be pulled by the it will be pulled by the proton, and it will collapse. The atom will collapse. But in reality, this does not happen. That is why you can say that this atom failed to explain stability. Failed to explain stability of atom. This model failed to explain the stability of atom, and it also failed to explain the hydrogen spectra. What is hydrogen spectra? We'll be discussing that in the next video. So this was about today's video, and the last topic was Rutherford's alpha ray scattering experiment. This also failed because of classical laws of electrodynamics, and it did not explain the stability of atom. I hope you have enjoyed today's video. In today's video we learned a lot, and please subscribe to this channel if you are new. Like this video if you liked the video, press the thumbs up button. Subscribe to this channel if you are new. Share this video to your friends if you like this video. See you next time in the next video. Thank you and goodbye.